Hi guys, welcome. We are going to be looking at this data set for US grocery store sales from 2021 January until 2024 July. And we are going to build a Monte Carlo forecasting model on this. As you know that any time series data may have the seasonality component, may have the trend component, and it may have the random component. So what we're going to do is that first we will deseasonalize this data set, and then after that we will detrend it. So we will end up with just the random errors that we're going to be assuming that all that's remaining is the random movements, and then we will just identify the mean and the standard deviations for these random errors. Then we'll create some random numbers, errors, and we will put those random errors back to the forecast. And then we will trend it back and seasonalize it back. So what's going to happen is that then we would have the chance to simulate that randomness in the data set. So the first thing is what I did here is that I removed the last three, just left them there so that I will see how good our model is going to forecast these 3 months. Then we'll also look at how it forecasts the remaining months as well. And then I'll only use this part up to period 41 to build my model. So I'm going to call this part, these are my sales. So let's just name that range as sales. And name this range as period. And name this range as months. Okay. And I'm not going to be using the year information there in my forecasting, so it is staying there. And what I'll also do is that I will just find my seasonality indices first for this data set, and then I will deseasonalize data. So if I look at this data set here, the sales data, and just by inserting a chart, I kind of see that there are some repetitive movements, so that kind of indicates that there's seasonality in the data set. So let's just take a look at what kind of seasonality that we have in the data set. And to do that, I will just use my range here. So I'll just find the average for January sales. So I'll use average if, and range, criteria, and average range. So the range is for the criteria, so that is months, and the criteria if that matches Jan, and then the average range is going to be sales. Okay, and that is this is not a percentage here, so this is essentially that's the value that I found here is 65,813 is the January average. So that means that's the January average. If I divide that by the grand average, then I will end up with the measure how strong the sales in January are compared to the overall sales. So to do that, let's just undo that and just divide this by average sales. Okay, so that's 93.15%. So that's kind of indicating us that sales in January are about 7% less than the sales overall. And I'll just need to just drag this instead of double clicking there. And what I realize here is that the sales are highest in November, so 107.74%. And this is 7.74% more than the average. and the sales are the lowest in January. Okay, so that's the seasonality there. So what I would do now is that I am going to now take this sales amount and I will divide this sales amount by the seasonality index to find the deseasonalized data. So if the sales in January are lower than average, by dividing that by this 93.15%, it is going to raise it and it is going to just deseasonalize it. If this number is bigger than 1, so it's 107%, it is going to make it lower, so it is going to decrease it. But to be able to just grab the correct seasonality index, what I need is that I'm going to be just using the XLOOKUP function, and assuming that you guys have the XLOOKUP function in your Excel version. If you don't, you could just use the VLOOKUP function or the index and match combination, and I'll just use the XLOOKUP here. So lookup value is Jan. Where do I look for that value? In here. And I'm going to be putting a $sign for 5 and 16 because I will copy these down and I just want this to stay in that place. And the return array is going to be here. And I did not name these ones, so it's okay if I just make a reference. And now the deseasonalized data is 68,413 for January. So let's just take a look at here how this looks, okay? And I will just look at the chart, and you're realizing now that, and this is the one, okay? You're realizing that now it is removing the seasonality, and there's not much seasonality here. So there's like two big seasonal indices there. So it kind of smoothens the line there. But there's still a trend here. So what I need to do is I'm going to remove the trend as well. And what I want to do is that I am not going to use this part. It could just stay there, this seasonalized data, but let's just remove them, okay? So because we're assuming that we don't have that data. And now I'll come here, and now I'm going to find the trend intercept and the slope values. And what I'll do is that I'll use for the intercept, I am going to use the function intercept. And then the known y's are the sales, x's are the period. So it's just looking at over time how the line, what kind of an intercept does the line have. And that's the intercept. And the slope is going to be the same thing. So the y's are the sales, and then the period. That is 274. So now this data set here, deseasonalized data, has an intercept of 64,785 and a slope of 274. So what I need to do now is that I'm going to find that linear trend for this data. So that is going to be here. Linear trend for the data is the intercept, and use the $sign on it, plus the slope times the period, and that's it. And that is 65,000. Double click on it, and then I can keep them there because I will just use some of those later on. And now I will detrend the data. So how would I do that is I am going to remove from the deseasonalized data, I'll remove the linear trend forecast. And I will just end up with assuming that this is my random error. Okay, so let's just delete this as well. So let's just take a look at this detrended data here, and just a line chart. And you're seeing that there is randomness around this 0. if I want to kind of look at this in terms of the box plot, I see that there are two outliers in my errors, the random errors there. And if I look at my there's some concern about the normality assumption there, but not too much. And then I will look at the histogram. Does it look like a normal curve? These are kind of visual observations. What I need to do is that I need to maybe implement the normality test on it. And what I could do is maybe I can just go to the data tab and the data analysis tool to see in the descriptive statistics. And then my input range is this de-trended data, and the labels are in the first row. I'll just look at the summary statistics for it, and I'll just click OK. So this is the de-trended data. The mean is about 0, so we expect that to be there. So the mean is 0 because those are the random errors just around that linear trend line. And this is my standard error. And what I have is that the median is 6.93. So the median is a little larger than the mean. And we have the minimum of negative 5,600 and maximum 3,300. And you look at the kurtosis, the skewness measures as well. I would recommend, if you're going to be doing this, maybe you can look at it in terms of just do a regular normality test. But if visual observation is sufficient enough, we are just trying to forecast. So I'm just going to assume here that these are just approximately normal. Okay. So the mean is 0, and then the standard deviation is STDEV for the sample and for the de-trended data, and that is 1,896. Or the standard deviation is here. Okay, so this 1,896 is there. Okay, so what I'll do now is using this statistics for the random error, I am going to be just creating my random errors, and that is going to just be added on top of every data point here. So the first thing is I will have my random errors somewhere here. Okay, so let's just say that using this mean and the standard deviation, I will just create that random error, and I will, instead of just using this de-trended data. So this de-trended data is something that I use to find the standard deviation and the mean, but now I will just add a randomly generated de-trended data to each of these, and then I will add the linear trend on it, and after that I am going to just add the seasonality on it. So maybe I'll just add one more column here, and here I will say that the simulated random the generated error. Okay, error. Now here I'll just use that using the normal distribution, and if it matches another distribution, you could just generate random numbers from that. And I will just create a normal inverse function, and the probability is going to be RAND, that is just a random number with the mean value of 0, and that is going to take the F4 here, and then the standard deviation of M19, right? Which is the number that's right below that. So that is my randomly generated error there, okay? So now these are, every time if I press on F9 on my keyboard, these errors are going to be randomly generated. Now what I'll do is that I'm going to add this randomly generated error back to my linear trend forecast, okay? And that is going to make my deseasonalized sales. And then I will seasonalize them and I'll find my forecast. So how do I do that is find now, let's say, what should I put here? I'll say Monte Carlo deseasonalized, okay? And then it is going to be just adding this value to the linear trend forecast back. And double click on it. And after that, these are my deseasonalized values with the random error, that randomly generated error. Then I am going to add just adjust this by the seasonality index. So in that case, I will just use this number. And now I will multiply that number. And if the month is January, it's going to be multiplied by January sales, because we know that we need to seasonalize this back. So that is, then I'll use the X lookup again. And lookup value is Jan. And then lookup array is here. And we'll just use the dollar signs, comma, and these are the indices. And these are also dollar signed, and close it. And enter. So now, as you see here, 66,996 turned into 62,405 because this is January and the sales in January are lower. And we'll double click on it. And now it was 61,000 to 57,000 because randomness changed. So the random error just appears to be a difference. So we'll just get rid of these ones for now. So I'll just create those later on. Okay. So for now, let's just focus on this part. And then we have there, this is my Monte Carlo forecast. Okay. So what I'll do now is that let's just take a look at how this looks compared to the actual sales. And then we will just generate multiples of those. Okay. So this is my actual sales. And these are my Monte Carlo forecast sales. And let's just insert a line chart. And if I press on F9 multiple times, what's happening here is that I am simulating my forecast. Right now, the simulation is done on the existing data, but we could now create the forecast for the future months, and we will have the forecast for values for those months, and we will simulate them and find the average for those. So to be able to do that now, we are going to, so these are my deseasonalized data, right? So this is just taking these values and just deseasonalizing them. And these are my just the linear trend forecast. So the linear trend forecast is just basically just looking at the intercept and the slope. So I can copy this down and I can find all my linear trend forecast. And then these ones are looking at the detrended data. We are not going to use it because we are not going to regenerate that. Okay. So what we have is that we have the random data using those two parameters. So we will just copy this down. So this is, and we have these ones that are going to depend on that as well. Okay. Now let's take a look at the Monte Carlo forecast. Okay, just one more time. And then also the season, not just that, sales versus the sales versus Monte Carlo forecast. Okay, and I'll insert my lines here. As you see here now in this chart, this part is my forecast for the future period. So if I press on F9, I'm seeing how that changes, right? So that's kind of the Monte Carlo forecasting does, is just it just creates the using the randomness in the earlier periods and assigns the randomness to the future periods. So in that case, what we'll do is we are going to be looking at here, for example, these are my, to validate what's happening, we are essentially getting like here 78,000, but I mean, the next time I try, it's going to be different. So what I need to do is for these months, for January, May, June, July, August, all of these, I need to just simulate this for enough number of times. Okay. And those are June, July, August, September, October. Are they the months that I'm looking here? It's May to, let's say, November. Okay, so let's just say here, this is May. And that's June, May, June, July, August, September, and October. So let's just take only these and paste them there. Only do our simulations on May, June, July, August, and September. So how we do that is that we will grab the forecast for May, and that is, forecast for May is this value. Okay, so this is May forecast, Monte Carlo forecast, J42. And then June forecast is J43, and July is J44, and August is J45, and September is J46. And let's see if that is correct. So that is J46 is September, correct? Yeah. So those are my references for those months, and this is equal to J46. And this is just one instance of my simulation. I need to have enough number of instances of the simulation so that I can get some measures of these results. So to do that, I am going to highlight these references. And then I am going to press Control Shift and down arrow 2 times and select that range. I will create 1,000 simulated numbers for each month. And after that, I will go to the Data tab, What If Analysis, Data Table. And what I want Excel to do is that I want Excel to refresh these random numbers 1,000 times. And in these columns. So here we are putting these values in columns that we are generating for every reference. So that means this is a column input, but we are not using any input. We are just saying these are trials. So data table usually requires an input, but for simulation purposes that there is no input, we can just refer to a blank cell. And any blank cell is going to be sufficient. It's going to be okay. So we click OK. And here we go. We have just 1,000 randomly generated forecasts for each of these months. So what is the mean here for the simulation results? So the mean is the average. An average of this 1,000 is there, 75,000. So this average is also going to change every time. but it's not going to change a lot because it's the average of this 1,000 numbers. So the median is, I can just use the quartile function, quartile, and array is this, and then comma, this is the median, second quartile, okay? And then median, it happens to be what? It happens to be the same number as the mean. It's very close, okay? And then I'm going to be grabbing and copying this across. 25th percentile is going to be, I need to just maybe use this and just use the F4 key to put the dollar signs in. And grab this down, and then I will use the 25th percentile. I'll use 1 and copy this across, okay? And the 75th percentile, use 3 and copy this across. So if I look at the May forecast, so let's just look at the insert histogram of this. As you see here, it kind of follows a very nice normal shape and normal distribution shape. And if you look at the box plot, then there are some outliers in each end, but not too many. So we are now seeing that here, that the mean value of my May results and forecasts for the randomly generated values, the mean is 75,751. If I only look at the 25th to 75th percentile of these, and it's going from 74,538 to 76,990. If I also look at maybe the histogram here, I would expect them to be maybe somewhere around 71,000 to 79,000 and so on, right? So this is, if you want to kind of, for example, figure out what is the likelihood that this sales in May is going to be lower than a certain amount, you can certainly find that. So maybe we could do that as well. So let's take a look at here. May sales are 73,990. So what is the chance that here, if we assume that 73,990, if we didn't know that, and to be able to just determine what would be the sales in May, to be, what's the likelihood that it is going to be less than 73,990, then I can just use the count if function, and here, and range, and the criteria is going to be less than, and criteria is my if, and the criteria is less than 73,990. And then I'll divide it by this count of each of these cells, okay? Count of all the set, which is 1,000, okay? There are 1,000 of them. And this less than symbol, I think we're going to be putting in quotations here to be able to make that. So there is, it's telling me that this is 0, but let's see if this is a number. So it's 19%. So 19% of these randomly generated values are less than 73,990. And at least 73,990 is about 81%. So I think we are good in terms of just getting close to that, the actual value there. And if I look at the actual value for June, 76,000, July, 76,000, and it is going from 76 to 79,000, 76 to 79,000. So that means it looks like we are in a good shape. So we should expect now then the sales in here for August and September. Maybe if I only consider this 25th to 75th percentile, so I would expect somewhere in that range, 74,000 to 77,000 and 77,000 to 79,000. How do we check? We'll have to wait for those months, or if we have them, we'll look at them and see if we are accurate. And we know that all forecasting models are wrong, and this is just one implementation of a forecasting model, and it is the Monte Carlo implementation of Monte Carlo forecasting model. So let's see here. Let's try one more thing before we end this. If I grab this year, month, and sales and the period, okay, if I grab these, and then if I go to the data and forecast sheet, and here we go. We have done a lot of work, and Excel is just giving us the future forecasts, and it also gives us some kind of a range. It's a confidence range there. And we can also generate that the 95% confidence interval from those forecasted values. But let's see if I want to just go from, let's say, 41 to 46, and this is my forecast. And let's say if I include the forecast statistics, and let's see here, how are we going to just turn this into the results. So we have that. So we are going to create this. Where is my OK button here? I'm just trying to find where it is. Okay, so I should have it somewhere there. And we're creating this. And let me just say enter. Okay. And let's see how this looks here. Not that. This Monte Carlo forecast. And Excel is using, I think, the Holtz and Winter model to do the forecasting. And let's see what forecasting results Excel gets for these months. And this period 42, 43, and 44, 76, 76, and 74. So let's see what we have here. 42, my forecast is 76, 76, and 70. Where is it, my forecast? Let's take a look at my average forecast here and maybe grab Excel's forecasts for these periods. 41 to 46. And these are the ranges for Excel there, okay? So go back here and maybe just put them somewhere here so that we could easily see those. And just paste special, transpose them, just the values, and okay. And these are just some kind of numbers with, let's just ignore the decimals there. And what are these? So that with Excel, these are from 41 to 46. So these are period 41 to 46. And period 41 to 46 are, so it looks like 41 to 46 are from April to September. So I'm going to look from May to September. Okay, so let's just grab this, May to September. And I'll put them here at the top. Not this here, May to September. So here, these are Excel's forecasts, and 76,000, 76,000, 74,000, and we have this mean value 75, 78, and 77. And Excel thinks that August is going to be 75. We are having August to be a little larger than that. And the actual numbers for those months are, the actual numbers are 73, 76, and 76. And those are the actual numbers. Okay, those are the actual numbers. 73, 76, and 76. So these are within the Excel's range. Excel has a larger range here because it's looking at the 95% confidence interval there. And we do not know if Excel is better in forecasting, but the simulation approach is really giving us more information about the data, and it is also giving us the seasonality information, if certain months are better than or just more sales than the others, just to see those patterns and also see the trend. And we are more, I think, we understand the data set better by just doing it in this way. But with Excel, yes, we can just create these results right away, but we do not know actually what is happening, right? So I would recommend that we just use our own approach rather than just using Excel's forecast sheet. And that's it for today. Thanks for watching.